So what I did for the next two sections is I actually put them together into one lesson, and the reason being is because they are very similar. They use the same theorems and the converse of those theorems. So you're going to be talking about parallelograms today. So the first thing is, what is a parallelogram? A parallelogram is a quadrilateral, so something with four sides, where both pairs of opposite sides are parallel from each other. So your first theorem says, if a quadrilateral is a parallelogram, then its opposite sides are congruent. So if I have a parallelogram, every time my opposite sides will be congruent. Then the next piece is more vocab, where it's talking about consecutive angles. Those are the angles of a polygon that share a side. So for example, in this parallelogram, B and C are consecutive angles. The reason I was pointing that out is because in your next theorem, it refers to a consecutive angle. So the next theorem says, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So if I have a parallelogram, these two angles, these two angles, these two angles, or those two angles, all will add to 180. Lastly, on this front side of your note-taking guide, the theorem says if a quadrilateral is a parallelogram, then its opposite angles are congruent. So if I have a parallelogram, then B and D are congruent to each other, and A and C. So a lot of that was just introductory stuff. We have one more, and then we'll actually start doing some more solving. So theorem 6.6 says, if a quadrilateral is a parallelogram, then its diagonals bisect each other. So if I have a parallelogram, then these diagonals, which means it's a line connecting the vertices, those will bisect each other. So remember, bisect means it will cut it into half. So from here to here and here to there will be equal to each other, and the same thing with the other. So now we're actually going to do some math and apply what all of those theorems were saying. So your first diagram, you have a parallelogram, and it's asking you to find what x is. So if you go back to your theorems, theorem 6.4 would be the one that we want to apply, because the consecutive angles will always be supplementary. So I can add these two angles to equal 180. So 3x plus 7 plus 110 would equal 180, and then I just do some algebra to solve. So I combined my like terms and got 117, subtracted 117 from 180 and got 63, and then divided by 3 and got 21. So now let's look at number 2. Number 2 has another parallelogram, and it's giving me expressions for the outside edges. So that would apply to theorem 6.3, where your opposite sides are always congruent. So you can set those two expressions equal to each other because they're congruent, and then do some solving. So I would subtract 5x from 10x and get 5x equals 10, and then divide by 5 to equal 2. I would like for you to pause the video and try questions 3 and 4. Okay, after trying question 3, here's how I would do it. So notice that they give you expressions for all four sides. You know that opposite sides are congruent. So again, theorem 6.3 would apply, where I would just set opposite sides congruent. So you can use either pair. So I used the top and the bottom, set them equal to each other, and then I solved it. So that means I subtracted 2x from 3x and got 1x. Then I added 2 to 6 and got x equaling 8. So then for the next problem, they give you an expression for all four angles, and you have two different ways you could do it. You could do consecutive angles that are supplementary, or you could do opposite angles are congruent. I set it up that opposite angles are congruent. So I set x plus 35 equaling 2x minus 5, and then I did some solving. So I subtracted 1x from over here, and then added 5 to 35 and got x equaling 40. Now let's try number 5 together. So on number 5, similar to the last, where you have an expression for opposite angles, so noticing that those opposite angles would be congruent by theorem 6.5, so I would set them equal to each other, subtract x, and then divide by 2. So my answer would be x equaling 30. Pause the video and see if you can do question 6. So on question 6, you're going to see that they're going to give you diagonals and they're going to give you an expression for half of the diagonal. So theorem 6.6 would apply because diagonals will bisect each other for a parallelogram. So I would just set the two expressions equal to each other and solve. So I subtracted 3x from 4x and then added 1 to 4, so I got x equaling 5. So that takes care of everything from section 6.2, where it's just introducing to you properties of the parallelogram. The next piece is, if I gave you a quadrilateral, how would you prove that it is a parallelogram? So I gave you a huge box at the top to summarize everything that you just did. So all of those theorems that we just got done discussing, the converse of that is how you would prove if it's a parallelogram. For example, I can show that it's a parallelogram by showing that both pairs of opposite sides are parallel. I can prove it by showing both pairs of opposite sides are congruent by theorem 6.8. I can prove that an angle is supplementary to both of its consecutive angles by theorem 6.9. I can prove that both pairs of opposite angles are congruent by theorem 6.10. I can prove that the diagonals bisect each other, and that's theorem 6.11. And you can also prove that one pair of opposite sides is congruent and parallel. So that one's a little bit different than what we've had. But notice that these 5 here are all theorems. I did not put those on your note-taking guide because this box just summarizes what you need to do. So if I'm going to prove that a quadrilateral is a parallelogram, it has to fit one of those things. So that's what this bottom section is all about. So let's look at the first row and then I'll have you try the second row. So on the first problem, it has you giving a parallelogram and then notice the tick marks so that my opposite sides are congruent. So yes, it would be a parallelogram, and my explanation would just be both pairs of opposite sides are congruent. Number 2, I see that I have opposite angles congruent. Well, that matches that, notice that in your, fourth one down, it says both pairs of opposite angles have to be congruent. So in this case, my answer would be no, because in that fourth one, it has to be both of them, just not one set. And then number 3, I have one set of parallel sides, and I have that same set congruent. That fits that very last piece in that summary box. So my answer would be yes, one pair of opposite sides is congruent and parallel. So now I would like for you to try the bottom row and see if you can get them right. So on the bottom row, number 4, I see that I have my diagonals bisecting each other. That's what these tick marks are saying. So this would be yes, because the diagonals are bisecting each other, which is theorem 6.11. Number 5, now notice that we have the opposite angles parallel and both pairs, so this one would also be yes, because both pairs of opposite angles are congruent. And then last, number 6, notice we have both pairs of opposite sides are parallel, and that is also yes, and that's by the definition of a parallelogram. So both pairs of opposite sides would be parallel for that last piece. Okay, so at this point we've just covered 6.2 and 6.3, which is talking about parallelograms. So if you still have any questions, please let me know so that I may help you, otherwise start on your assignment.